Hello children, welcome to channel Sube. Children, today I am going to discuss question number 43 from the MCQ part of 2021 Physics New Syllabus paper. A conducting ring is connected to a circuit as shown in the figure. Conducting ring. So this word is wrong, children. If it is a conducting ring, there is no resistance. So there is a mistake in this question. If it is a conducting ring, there is no resistance, so the current is constant. So then if it were like this, the answer should be this one, but that is not they have meant. They have meant that this ring has a ring has a certain amount of resistance. So this word is wrong, therefore it should be a resistance ring with a resistance. So however, let us solve this problem. So they say point A is fixed, but point A is fixed, so this wire is fixed to this ring, but point B can be moved along the ring so that the angle theta changes. That means this pointer, point B, this end of this wire can move. We can take it from place to place like that. We can touch this ring. That is the meaning. It is not fixed here. We can move it. It is just there. We have to touch it. So the theta changes. The cell and the ammeter are ideal. They are ideal. That means internal resistance is 0 here. So this one has no resistance. That is the idea. Which of the following graphs best represents the variation of the ammeter reading I with the angle theta? So there are 5 graphs they have given. So let us try to answer this question. So children, therefore I change that word, because when there is a wrong word, conducting is wrong. It should be a resistance ring, a ring with certain resistance. So here also it should be like that. So now this is how we have to face this problem. In the lesson we teach if there is a resistance ring, this is a resistance ring. Even though we draw it smoothly like this, actually it must be like this. It is a resistance ring. It has a resistance. It is not a copper wire. It is a resistance. But we don't draw normally like this. We draw like this. So what we teach in the lesson is, what you have been taught is, so if we measure the resistance using a resistance meter, you can use the multimeter, normal multimeter. The switch you have to turn to the ohm range, then you get the reading. So if you connect the wire like this, the probes of the meter at the points diameter at the beginning and end point of the diameter. So this one is the diameter. So this diameter points have the maximum resistance. If we plot a graph, resistance to y-axis, so maximum is at this diameter point. So this one is the maximum. So if we change this wire to any other place, then the resistance value decreases like this. So if you take the wire to this place, the resistance is more smaller. So like this we get a graph like this. If we take the theta to x-axis, So this theta, this is the theta. So if the theta is smaller, so here then we get lower values for the resistance of the net means this circuit. So if we come to this place, what is the angle? Then 180. So at that point, when the angle is half circle, that means 180 degrees, we get the maximum resistance. And after that we go beyond. When we go beyond like this, so we came from this way. If we go beyond, means the wire we place here somewhere, so the angle is bigger than 180. The angle is bigger than that. So here now the angle is something like this, theta. Then we are somewhere here, so the resistance is again decreasing. So like this the graph is symmetric. The graph is symmetric. Like this we get the graph. So what they ask is not the resistance, what they ask is the current I. So we know, according to Ohm's law, the voltage is constant. The voltage is constant, the battery is not changed. So here if we plot I instead of resistance, what happens? We get at the maximum resistance the current is minimum. At the maximum resistance the current is minimum, but it is not zero. To be zero, this wire should break somewhere. This wire should break, otherwise we get a certain current, because still this loop has a certain resistance. So the current doesn't go to zero. So the invert graph of this graph we get here for I. So invert this one like this. When the resistance is very low at this place, at ends resistance is very low, so we get the highest current. So like this. So this is the graph we should select according to this correct question. So this one is the answer, first one. So I think you understand, this is not a big issue. We learn all these things in the classroom, just you have to use your brain to decide what is going to be the value of the current according to the resistance change. So let us check the answer. Question number is 43. 43, the first one is the answer. So it is a easy question. This one is a easy question. So let us do some more activities. That means let us do some target questions. I can prepare. Children, actually we can do this practical. It is a very pretty practical. You can do it using a hot plate coil. You can't use copper wire or an iron wire. You have to buy a hot plate coil. Hot plate coil. From an hardware shop or an electrical item shop. So it is about 100 rupees or 150, something like that. So that coil is like this. You have to bend it a little bit. Easily you can bend it like this to make a circle. You don't stretch it. Don't stretch it. Without stretching, carefully you have to turn this two ends, connect these two ends using a small piece of copper wire, because you can't bend this hot plate wire because it is very hard. You have to connect using small copper wire these two ends and make a loop like this, and then you have to take a cardboard and place this ring on the cardboard, and using some sellotapes you have to stick it to the cardboard so that it doesn't move here and there. Then using a tape, a tailor's tape, which is easily flexible one, using a flexible tape, you can measure the length from this diameter line from a certain place. You don't have to find out the diameter actually. From a certain place you have to start and measure the length like this, say 2 centimeter, and again 4 centimeter, like this, 6 centimeter. So you mark using a pencil on the cardboard, 6 centimeter, 8 centimeter, 10 centimeter, then 12, 14, 16, 18, 20, 22, like that. You have to mark the lengths. Then using an ohm meter means you can use a multimeter. So you have to turn the switch to the ohm range, like this. You have to turn the switch to the ohm range, suitable ohm range. So you have to take the negative probe like this and connect to this starting point, and the other probe you have to place from place to place, first at this 2 centimeter and then at 4 centimeter, like that. So you get a reading here. So that reading is the resistance. So this length L, 2 centimeter, 4 centimeter, those are length. We don't measure theta as they have done in this problem. It is difficult. So measuring length is easier, and R. So you make the table like this, data table. So first 2 centimeter, the length is 2 centimeter, then 4, 6, like that. You measure, and the resistance you get like this, say 4, 6, 8, like that you get. All together the total resistance is something around 60 ohm for a coil like this. So at this point 4, 6, 8, 10, 12, the diameter is at 12. So at the length 12 centimeter you get the maximum resistance, that is 30 ohm. 30 ohm normally, usually 30 ohm, because this one is 60 ohm totally. So parallelly connected when we place the probe here. So there are two parallel resistors like this, the upper one and the lower one, like this. So totally this one is 60 I said, so this one is then 30, then this one is 30, 15, you get 15, not this value, not 30, you get 15 according to theory. So 8, 10, like this, it increases, and 50. Again when you go this way, beyond that you have to go along this way to the beginning itself. So when you go here 14, then 16, like that, again what happens, the resistance decreases. 14, 16, when you go there, again you get lower values. That means say 13, 12, like that, 10, 8, 5, something like that you go, but you don't get 0 because there is a certain resistance. Practically you don't go to the you don't go to, you can't, you don't get 0 value. So however this is the practical, easily you can do very nicely, it is very pretty. We get the graph. You can use an Excel file to plot the graph if you have difficulties plotting graphs on graph papers. So I have done very nicely, we get the result. So that is the practical actually we do. So this one is, that is why I said this one is a resistance ring, not a just copper wire. So I have tried without knowing, I have tried using a copper wire, but you can't measure measurable, you can't get a measurable resistance using a copper wire. Even I used that we call iron wires, normal wires, what we call binding wires, so that also not successful. So you have to get a hot plate coil for this. So children, that is something additionally I said, if you do these types of things, this physics, the subject physics is very interesting. So children, I have designed a target question for you. Let us see what is it. A resistance ring is connected to a circuit as shown in the figure. Point A is fixed, but point B can be moved along the ring so that the angle theta changes. The cell and the voltmeter are ideal. So here is a voltmeter instead of ammeter in the previous question. Which of the following graphs best represents the variation of the voltmeter reading with voltmeter reading V with the angle theta? So now try this question on your own without watching the video. So you have to take a screenshot of the question and the graphs. Now take a screenshot and take a screenshot of these graphs, because if I zoom out, you can take one screenshot like this. I don't know whether it is clear, then the letters are smaller, but however it's up to you. So now pause the video. Honestly, you do it on your own without watching my solution. Pause the video now. I think now you have done. So I am going to solve this. So now voltmeter is there. You can come to the decision using this side or using this side, because the voltmeter is common to the both circuits. Using this side is very easier. You don't have to think about changing resistance and theta, everything, because this battery, the cell, has zero internal resistance. The voltage between these terminals is constant, that is equal to EMF, electromotive force of this E is a constant, so the voltage is constant. Voltage is constant, that means even though we change these parts of the circuit, the voltage doesn't change, because the hands of this voltmeter is connected to this battery like this, so it is constant. Therefore the answer is this one, voltage is constant. Or otherwise you might have tried thinking about this part, like the resistance increases like this, and then the current change like this, V equals IR, then when R increases, I decreases, so therefore this one is constant. That also okay, that also doesn't matter, that also you can come to the answer. So however, if you have choose the correct answer, the voltage doesn't change. Therefore if it is the answer you have chosen, you are good, you are genius, you are successful. That means you can current electricity, you know current electricity, you can go further. So let us go to the question number 2 now. So children, I designed another target question. The question number 2, a resistance ring is connected to a circuit as shown in the figure. Point A is fixed, but point B can be moved along the ring so that the angle theta changes. The cell and the meters, so there are two meters, ammeter and voltmeter, are ideal. If the ammeter reading is I and the voltmeter reading is V Which of the following graphs best represents the variation of Vi multiplication with the angle theta? So there are graphs, they have taken Vi multiplication to the y-axis in each graph, theta to the x-axis in each graph. So now what you have to do is take a screenshot of this question, part 1 and part 2, like this you have to take, if you want it with this bigger letters, otherwise I can zoom out like this. If this one is suitable, you can take a snapshot at once, so otherwise you have to take 2 snapshots, I think. So now take a snapshot, that means screenshot, what we say. You can take a screenshot. If you are using the computer, you can use control and print screen key. There is a key called print screen, so it is labeled PRTSCR. So like this, sys RQ, somewhere sys R Q is also there. So there is a key on your keyboard like this, print screen we say, control with control and print screen. So you can get the screenshot and open Paint, Microsoft Paint or some app like that, and copy paste control V. You have to press control V, then you can get the screenshot. If you are using a phone, the button, the volume button and the start button, no. So this one now you have to take the screenshot. So otherwise I will zoom out so that you can take one screenshot altogether like this. I don't know it is whether it is clear or not, so that's depend on your. So now I think you have taken screenshots. So now pause the video, don't watch my answer how to solve it, don't watch it. Honestly you have to do, you have to solve the question on your own, because now we have done few questions in this nature. Now pause the video. Now I am going to start. I think you have done it. So here the voltage and ammeter reading. So as previously, the voltmeter is connected to this circuit and this circuit. So the ammeter doesn't affect because it has no resistance, because they say meters are ideal. If the voltmeter is ideal, it has infinite. It has an infinite resistance. That means no current pass through this voltmeter. And if the ammeter is ideal, that means without any resistance, the current totally pass through the ammeter. So the cell also is ideal. That means simple R is 0. Simple R is 0. Internal resistance is 0. So regarding this part, as we did in the previous question, the voltmeter doesn't change. This one is a constant. Voltmeter value is constant. So what is the ammeter value? Ammeter value increases as previously. Ammeter value not increases, decreases, because the resistance increases like this. The ammeter value therefore decreases. So V equals IR. So V is constant. Therefore, when I increases, when R increases, this one is R. this one R. At the first part I am talking about, the second part it is decreasing. At the first part R increases, so I decreases, keeping the voltage constant, so I however decreases, so like this, I however decreases. So if we multiply it by a constant, V is constant, so this graph a little bit moves upwards. That's only happen. That's the thing that only happen. So the answer is then this one. Because the shape doesn't change. If this V value is something like 0.5 or something like that, if it is not a whole number, then very little bit this graph will move up like this. So it doesn't, we can't see any change. So this is the answer. However, first one is the answer, because the V is constant, the current change as same as in the previous question. So when we multiply this current by a constant, V is constant, then all the values little bit rise up like this. So the shape doesn't change. So therefore the correct answer is this first one. So if you have successfully done, so you can be happy, you are genius. So let us now go to the third one. Children, I have designed another question. I just changed, made some alterations, but it is actually a new question for you if you forget the first original question. So next time if this one is given, you even don't know that in the previous year that they had given such a question, some things equal to the new one. You will never identify even. So now let us try to do this question. A resistance ring is connected to a question number 3. So this one question number 2, this one question number 1. We are doing target questions. If we do target questions like this in the same problem, changing little, then it will go to your head, the theory and everything. So that is very successful, I think. So therefore we do questions like this with little alterations, not a big change. A resistance ring is connected to a circuit as shown in the figure. Point A and point A is fixed, but point B can be moved along the ring so that the angle theta change. The cell is ideal, so there are no meters. Which of the following graphs best represents the variation of power with the angle theta? Power. So you should know about power and choose the correct answer, correct graph. So as previously, you can take screenshots. Now this one, and if I zoom out, you can take altogether one. Right. Now let us pause the video. Honestly, you should do on your own. Then only you can be happy if it is if it was successful. So pause the video and start. So now I think you have done. I am going to show you how to solve this. Power is what? is the multiplication of Vi. So previously we discussed how Vi is changing. So therefore the first one is the answer. The word, only the word is changed in this problem. We haven't written it as Vi, but in the previous question we had given as Vi, but here we have given as power. So if somebody doesn't know power is equal to Vi, so he has trouble. Some people only know power is I squared R. Then again he has problems to solve this. The easiest way is to use this power equals Vi, the multiplication of Vi. So the answer is this one, first one, because V is constant here. V is constant because the battery is connected to this one. So simple R is 0, therefore V doesn't change. The V voltage is this one. This voltage is always equal to the electromotive force, capital E, EMF. Even though this resistance and current are changing, but V is constant, you can reach that decision even using V equals IR, because in the first portion the R increases like that, we know, and decreases after the second portion. That means after this place decreases, up to this place increases R. So current therefore decreases, current decreases in the first portion. So current decreases, R increases, so V constant. So that way also you can decide that V is constant, or otherwise you can decide that to this cell is the voltmeter is connected to this cell from other side, from the above it is connected to this complicated circuit, but from the bottom side it is connected to the cell. So until it is connected to the cell, the voltage between the cell is constant, therefore the voltmeter should be also constant. So that also you can get the answer. That means the voltmeter is the voltage is constant. So if this one is constant, we can write then what? We can write like this: power is proportional to I, because we can write this one as a K, proportionality constant. So we can get this one. So that is the shape of the graph. That is the shape of the graph. It is proportional to I, then it is multiplied by, so they ask power, so power is proportional to I. So previously we knew, not even previously, we already just now discussed this current is increasing and decreasing and increasing like this, decreasing in the first portion and increasing in the second portion. So that is the change in I. So power also should be like that. So this one is the answer. So since you have come step by step, this one is a easy question. This question may be easier because you have done already the second one. Otherwise, if we gave this question as a thunder without giving those first and second questions, you may not answer this. As a new question, suddenly if we gave this question, so you will be in trouble. So little by little we came up to this level, therefore you might see that this question is a easy one, so this is useless, like that you might think, because we came step by step. That is why it is easy for you. So imagine suddenly you are given these questions without discussing anything previously, but we discussed all these things. Then this question is a difficult one. So that means now you have gained your knowledge. That means if you feel this one is easier, now you have gained your ability and knowledge, everything, because we followed these steps. That is the result. That is the result. So let us go to another target question now. So children, here is the target question 4. A resistance ring is connected to a circuit as shown in the figure. Point P is fixed, but point B can be moved along the ring. The cell is ideal, this one. PQ is the diameter. PQ is the diameter. PB distance is L. The ammeter reading is I. When B is moved from P to Q this way, which of the following graphs best represents the variation of I with the length L? So children, what you have to do now, without watching my solution, take screenshots first of this question and then these graphs. And if you want a single screenshot, I can zoom out like this. I don't know whether it is clear. So if you want, you can take a screenshot now. So now what you have to do, children, pause the video, honestly answer the question on your own, then let us discuss. Pause the video. I think you have now selected the answer. You are done now. I think. So what are the alterations I have done? I have taken this battery into the loop, but the structure is same. So previously the ammeter was here at the positive side of the cell. Now I have changed it to the negative side of the cell, but nothing happened. Even though I change it like this, it doesn't affect the results. It doesn't affect the results. So the same circuit, it is the same circuit. So when we are coming from this point P to point Q, what happens? We are reaching the diameter point. So the resistance therefore must increase like this. The other half doesn't go, because we don't go along this circle, because in the question they say from P to Q, only P to Q. Again Q to P we don't go. So therefore only this part. So the current is the inversion of this. That means when the resistance is low, the current must be higher. When the resistance is higher, the current must be lower. So like this, the current curve should be like this. So this one is the answer. Current curve is like this. So if you have successfully solved the problem, you can be happy of yourself. You are good. You are genius. Children, let us do the question number 5 of target question. A resistance ring is connected to a circuit as shown in the figure. Point A is fixed, but point B can be moved along the ring so that the angle theta changes. The cell and the meters are ideal. There are two meters, voltmeter and ammeter. If the ammeter reading is I and the voltmeter reading is V, which of the following graphs best represents the variation of V divided by I with the angle theta? So graphs are like this. So what you have to do, first take a screenshot of this and this. Now this graphs. So if you wish to take a single screenshot, I can zoom out like this. You take this one. And now what you have to do, as previously, without watching my solution, you have to find the answer on your own. Honestly, honestly do it. Now pause the video. I think you have finished, you have done it. So everything is as the original MCQ question, but I have added the voltmeter. So what they have taken to the y-axis is V divided by I. What is V divided by I? V equals IR. So V divided by I is R. So they are asking is the resistance of this resistance ring. So we know that resistance is changing with theta like this, So the same thing is what they are asking. So this one is the answer, isn't it? It is the answer. They are not asking I as previously. They are asking the resistance, but in other words. They don't say directly we want the resistance. They say V divided by I is what we want. So the answer is this one, children. So if you are successfully, if you have answered, so you are genius, huh? So children, I think you are happy. I discussed the original MCQ question, this one 43 like this, and I designed this target question 1 for you and discussed how to solve it, and also I designed another target question number 2 for you and discussed how to solve it, and also I designed this target question number 3 and also I discussed how to do it, and also I designed this question number 4 and also I discussed that, and also this finally the target question 5 I designed it and discussed how to solve it. So I think you must be happy. So it is your obligation now to make me happy by subscribing, only if you haven't still subscribed to my channel, but don't subscribe twice, then press the thumb up button, give me a like, and also press the bell icon so that you can get the message as soon as I uploaded the video. And what else, share my link among your friends so that my audience will be increased. So if you help me like that, then I should be grateful to you. So see you tomorrow at 6 o'clock. Goodbye, children.